For thousands of years, humanity believed the night sky was simple. The stars appeared fixed, the planets followed predictable paths, and the universe seemed permanent and unchanging. Every civilization looked upward and wondered what existed beyond the visible lights. But every generation of science has revealed the same surprising truth: the universe is always more complicated than it first appears. The first major shift came during the early 20th century. Before then, many astronomers believed the Milky Way contained nearly everything that existed. The countless faint clouds visible through telescopes were thought to be small objects within our own galaxy. That idea changed dramatically when improved observations showed those faint clouds were actually entire galaxies, each containing billions of stars. Around the same time, astronomers made another revolutionary discovery. The universe was not standing still. Distant galaxies were moving away from one another, showing that space itself was expanding. This realization transformed astronomy forever. Instead of an eternal, unchanging universe, scientists began describing a cosmos with a beginning, one that had been evolving for billions of years. Today, decades of increasingly precise observations place the age of the universe at about 13.8 billion years. That estimate comes from several independent sources, including measurements of the cosmic microwave background, the expansion of distant galaxies, and the life cycles of stars. While scientists are confident in this number, they also recognize an important principle: every scientific model remains open to refinement when new evidence appears. Even our own galaxy continues to challenge expectations. The Milky Way contains hundreds of billions of stars, all orbiting a common center. According to gravity alone, the stars near the galaxy's outer edge should move much more slowly than they actually do. Instead, they travel at speeds that suggest an enormous amount of invisible matter surrounds the galaxy. This unseen material is known as dark matter. It does not produce light, reflect light, or absorb light, making it impossible to observe directly with ordinary telescopes. Scientists detect it only through its gravitational influence on stars and galaxies. Yet even dark matter remains one of astronomy's greatest mysteries. Recent observations from the European Space Agency's Gaia spacecraft have measured the positions and motions of nearly 2 billion stars with extraordinary precision. These measurements continue refining estimates of our galaxy's mass and structure. Some results suggest the Milky Way may contain less total mass than earlier studies proposed, forcing astronomers to improve models describing how dark matter is distributed throughout the galaxy. Rather than eliminating the mystery, these discoveries reveal how much remains unknown. Looking beyond the Milky Way introduces even greater surprises. Modern observatories can now detect galaxies whose light began traveling toward Earth only a few 100 million years after the Big Bang. Scientists expected these early galaxies to appear small, dim, and still developing. Instead, several observations revealed galaxies that already looked remarkably bright and surprisingly organized. Some appeared to contain enormous numbers of stars despite existing during the universe's earliest chapters. Others displayed structures that seemed more mature than many theoretical models predicted. These discoveries do not overturn modern cosmology. Instead, they encourage astronomers to ask new questions. Could stars have formed faster than expected? Did galaxies merge more rapidly in the early universe? Were conditions shortly after the Big Bang especially efficient at building cosmic structure? Researchers continue investigating each possibility. Every new observation improves computer simulations, helping scientists better understand how galaxies evolve across billions of years. At the same time, another revolution has been unfolding much closer to home. During the last few decades, astronomers have discovered thousands of planets orbiting distant stars. Before the 1990s, no planets outside our solar system had been confirmed. Today, the known population continues growing every year. These exoplanets display astonishing diversity. Some are giant worlds orbiting so close to their stars that their atmospheres reach extreme temperatures. Others are rocky planets located within regions where liquid water could potentially exist. One fascinating example is WASP 96b, whose atmosphere has been studied using advanced infrared observations. Scientists detected clear evidence of water vapor along with clouds and atmospheric chemistry unlike anything previously observed in such detail. Although this planet is far too hot to support life as we know it, its atmosphere demonstrates something remarkable. Complex chemistry is not unique to Earth. Instead, it appears throughout the galaxy, suggesting that the building blocks of planetary systems are widespread across the universe. As observations continue improving, astronomers are moving beyond simply discovering planets. They are beginning to study the composition of distant atmospheres, searching for chemical signatures that reveal how these alien worlds formed and evolved. Each discovery brings humanity one step closer to understanding whether Earth is truly unique, or simply one example among countless worlds scattered across the Milky Way. The deeper we explore the cosmos, the clearer one truth becomes. Every answer reveals another mystery waiting beyond the horizon. As astronomers continue exploring the universe, one lesson becomes impossible to ignore. Every breakthrough answers one question while uncovering several more. Instead of making the cosmos seem smaller or simpler, each new discovery reveals a universe that is richer, more complex, and filled with unexpected surprises. One mystery that continues to fascinate researchers involves the large-scale motion of galaxies. Across immense distances, galaxies gather into enormous clusters connected by vast filaments of matter, forming what scientists call the cosmic web. These structures stretch across hundreds of millions of light years and represent the largest known patterns in the observable universe. Yet some observations suggest that certain galaxy clusters move in ways that are not fully explained by nearby gravity alone. This phenomenon, often called dark flow, remains an area of active scientific investigation. While its cause is still uncertain, researchers continue studying whether these motions result from hidden structures, measurement limitations, or processes not yet fully understood. Another remarkable realization concerns what the universe is actually made of. Everything we can directly observe, including stars, planets, gas clouds, galaxies, and even ourselves, accounts for less than 5% of the total energy and matter in the cosmos. The remaining 95% consists of two mysterious components: dark matter and dark energy. Dark matter appears to provide the invisible gravitational framework that holds galaxies together. Without it, many galaxies would rotate too quickly to remain stable. Dark energy, meanwhile, seems responsible for the accelerating expansion of the universe, causing distant galaxies to move away from one another at an ever-increasing rate. Although both have measurable effects, neither has been directly detected in a laboratory. Understanding their true nature remains one of the greatest challenges in modern physics. Astronomers are also learning that measuring the age of stars is far more difficult than it may seem. One famous example is HD 140283, often nicknamed the Methuselah star. Early estimates suggested this ancient star might actually be older than the universe itself. Naturally, such a result seemed impossible. As observational techniques improved, scientists refined those measurements. The current estimates now overlap with the accepted age of the universe once the margin of uncertainty is considered. Rather than creating a contradiction, the star demonstrated how small improvements in precision can completely change our interpretation of cosmic history. To appreciate these enormous timescales, scientists sometimes use a simple comparison called the cosmic calendar. Imagine compressing the entire 13.8 billion-year history of the universe into a single calendar year. The Big Bang occurs on January 1st. The Milky Way forms months later. Our solar system appears only during the final days of December. Dinosaurs disappear on December 30th. And all of recorded human civilization occupies only the last few seconds before midnight on December 31st. This perspective reminds us that humanity has existed for only a tiny fraction of cosmic history. Meanwhile, powerful observatories continue pushing the limits of what we can see. The James Webb Space Telescope has revealed galaxies that appear surprisingly bright and well-developed only a few 100 million years after the Big Bang. These observations suggest that stars and galaxies may have formed more efficiently than earlier models predicted. Rather than replacing established physics, these discoveries encourage scientists to improve simulations and develop more accurate explanations for how the early universe evolved. Science advances through exactly this process. Predictions are tested. Unexpected results are carefully examined. New observations refine existing ideas. Over time, our understanding becomes more complete. Perhaps the greatest lesson from modern astronomy is not that the universe refuses to follow the laws of physics. Instead, it reminds us that nature is often more intricate than our first explanations suggest. Every telescope built by humanity has expanded our view of reality. Every spacecraft has carried us farther into the unknown. Every generation has inherited new mysteries from the discoveries of the one before it. The universe is not a puzzle with a final piece waiting to be found. It is an endless frontier, where every answer opens another door to exploration. As technology continues improving, future observatories will look deeper into space, study more distant planets, and investigate phenomena that today remain unexplained. What they discover may once again reshape humanity's understanding of the cosmos. Because throughout history, the greatest scientific breakthroughs have rarely marked the end of a mystery. More often, they have marked the beginning of an entirely new journey.